This is my project for EM3. So first I'll explain about Euler's method. So over here on the left we have the actual values of this graph for y equals to x squared plus x plus 3. Then over here we have the values for Euler's method for the same graph. So we're using step size of 1. So as you can see with this hand-drawn graph over here, right? This top line are the actual values of the graph, while this bottom line is Euler's method. So Euler's method is y1 or 2 equals to y1 plus h, which is your step size, times dy slash dx. Okay, so dy dx is the gradient, and gradient is delta y or change in y over delta x, which is change in x. So dy by dx, and then we multiply that by the step size, which is your delta x. So if we take dy over dx times dx, this just gives you your delta y, right? This means that your Euler's method is essentially y2 equals to y1 plus the change in y, so dy. Okay, so now moving on. In sheet 1, right, we have our formula, which is dy over dx equals to x squared plus 1 over y. So on the left here, we have the values for Euler's method over here. And on the right side, we have the values for the actual values, but more on that later. So for x here, we start with 0, because that's our origin. And then for each step size of, we take 0.05 for the step size. So each formula, C3, which is the previous value, plus 0.05, all the way down to down here, which is C22 plus 0.05. And then over here, we are dy dx, which is simply just x squared plus 1 over y, as you can see with these values over here. Then lastly, we have our y, which is d3, which is our first y, plus our step size times our dy dx over here. And then this extends all the way down, as you can see. Okay. And then lastly, for the approximation error, right? So we have a value of this over here. This is our Euler's method for y for y when x equals to 1. And then this is our actual value. So if we take these values and change and see the difference, which would be d23 divided by t24, right, times 100, we have an approximation value of about 0.1% difference from actually. And that's about it. Yeah, thank you.